Cool. Thank you very much for this opportunity to present. This is a new venue for me, so I apologize if I do not follow exact format or meet the expectations. But yeah, please share afterwards what you guys liked, what you guys didn't like, what you would like to see differently maybe next time. But I would like to first compliment Devin's presentation on St. Louis. Pretty cool. And I think it is very well connected with what my team is doing as well on the urban planning side. Just a few words about the AI prototypes team, the team I'm leading. And myself, I'm Dmitry Kudinov. I've been with Esri for 17 plus years, quite some time. And the AI prototypes team I'm leading right now has about 15 plus members. We have some virtual and contractors also joining us, working actually. Some of them are from ETH Zurich as well. We are working on the various AI projects related to the 3D space. This is feature extraction and feature generation, but primarily, and today I'm going to talk about our flagship project, the main project which we are working together with the CityEngine team is the urban massing generator. This is about AI-assisted urban planning. So urban planning, as we work with professional services as well on that side of the market, and how the professional services of Esri sees it and follows, is a fairly standard pipeline, which starts, of course, with current state assessment, which goes then into vision and strategy, feasibility study, then conceptual plan, which is converted into detailed master planning, and then related components development followed by the urban design stages. Well, urban planning is a well-structured discipline, right? And it is an art, but it is also driven by metrics, right? It is numbers driven. There are resources which need to be efficiently allocated, used to produce the desired outcomes. And the urban massing generator here occupies right now or influences and helps the planners to work efficiently within these three stages. The conceptual plan, particularly helping with zoning allocation, then goes into the detailed master planning through and with the help of raster generative AI model to build massing studies of LOD 1.3 buildings, and then goes into the related components development by using operations research. And if you are familiar with network analyst extension, essentially placing critical facilities, like for example hospitals or emergency response or schools, in optimized locations given the transportation graph, given the streets network of the plan, in order to maximize the pedestrian access to the residents and business hours population of my massing study. This goes along that Carlos Morena 15-minute or 5-minute city design concept, which we are taking very seriously here, and which we are optimizing for when working with our massing studies. So a little bit of a formal definition here, and why an urban massing generator, right? What does it help you do as a planner? Well, I will bear with me. I will read this lengthy definition, but I think it's worthwhile spending a few seconds on this one, because it's I think that's the core that's the core value proposition here of this project. So moving from the stage of conceptual plan to a detailed master plan involves multiple iterations of massing studies, which are each evaluated against quantitative and qualitative criteria. With scale, the process becomes increasingly time-consuming, even with today's procedural modeling tools. And I think, Devin, you mentioned in your presentation that the procedurally model buildings, yeah, they are indeed right now a very efficient way to get to highly accurate and meeting metrics building shapes, but it is fairly labor-intensive process to build large massing studies using those. So, and the UMG actually here enables planners to speed up this process through an AI-assisted massing generator, which allows users to input guiding criteria early in the process and rapidly explore large space of high-quality massing solutions. So it is an AI assistant helping urban planners through an iterative human-in-the-loop process produce scientifically driven massing studies. And scientifically driven aspect here comes from the user-driven optimizations focused on user-specified metrics. And here in this beta 1 version of the urban massing generator, which we just released a couple of weeks ago, and we are looking actually right now to connect with some Lighthouse customers to get the real-world feedback from them. Right now, that analytical components, the optimization component which we are using here, is based on the network analyst extension, and particularly the location allocation solver, which allows us on before and after the massing studies, pre and post processing in form of optimizations and display of the accessibility to the residential and business time population to different city amenities and services and critical facilities. It also helps with assignment of non-residential zoning categories to the vacant lots, for example. Right? I can also target a specific coverage, total coverage for a specific zoning category, non-residential zoning category. I can see what's my walking access to parks or to shopping centers is. I can place my fire stations, so the overall capacitated distribution of my population is under the minimum average travel distance. Right? So all of that right now is brought as a solution into the CityEngine. So it is not a native functionality of the CityEngine yet. We are going to collect first feedback from the Lighthouse customers and decide and flesh out, polish that functionality, and then decide on the inclusion into the CityEngine, whether it's worth it and when it is going to happen. Right now, it is a custom built solution on top of the CityEngine, which brings in the power of raster generative AI to build the LOD 1.3 building shapes, which allow for efficient evaluation or estimation of the population distribution, the residential population and the business population, business hours. And also the network analyst, which allows for efficient non-residential zoning assignment and also critical facility placement. So let's take a look at the pre-recorded demo here I have prepared for you. This is again a pre-beta version, so the work still continues here, and but I think you will be able to get the main idea how it works. Here we are looking at a portion of the streets network of Paris of about 8.5 square kilometers in size, and the blocks were built procedurally by just taking the polygons which are circumvented by those streets. And those blocks, this is where the planner operates and assigns first the residential population. Here, I already pre-assigned 3 types of zones, residential zones, so low density residential, mixed residential, downtown core, and an existing park right here in the middle. And I also have this a few vacant lots left, which I will be using network analyst to place efficiently non-residential zoning categories like mixed non-residential, maybe add some parks and ponds as well to improve the quality of experience for the residents and guests here. The road graph is the input here. And this road graph can be brought in, imported from a local GED database of a local government, from the local government cadastre, or imported from OSM using the get map data functional of CityEngine. It will work here. Or it can be even procedurally generated if you want, or it can be edited actually in the process as well. It's particularly important for the brownfield and infill scenarios. Brownfield, of course, first of all, when I can actually change my existing streets and rearrange the blocks generated here. This will also take into account the existing urban infrastructure. So you would be able to see as a user, as a planner, the not just the population distribution and the use of the city services, accessibility to them for the newly built area, but also you would see an impact on the existing infrastructure. Like, for example, if I have a few schools already existing, I want to know what would be the impact for on them from the newly distributed and planted population in here in the newly developed area, and vice versa, right? Can my newly built schools be affected or take in some of the existing students out there in the nearby existing urban fabric? Okay, so let's see the demo. So I got my streets. I got already manually pre-assigned some of the residential population here. Now let me here again, as I said, this is 8.5 square kilometers, very large area of Paris. Mixed downtown core parks. These are vacant lots, and which I'm going to be using here to place the non-residential zoning categories using network analyst automation. I will start with just creating a duplicate scenario inside CityEngine, which is quite handy because I will be able to compare side by side different options. As a planner, for me, it is very important to see, right, am I moving in the right direction? Am I improving the thing, the story? So here I'm going to place parks within 500 meter walking distance, and I will be looking for 5,000 meters at least size vacant lots to place those parks for in 500 meters of residential within the from residential population. And here we got the accessibility map. This is essentially like a color ramp showing and displaying for the residential blocks how far away are they from the assigned blocks of the target zoning category. Right now I'm looking for parks. Right? And here you can see that all of them are this light cyan color, which means that they are all within the 500-meter cutoff walking distance, which I mentioned before. I got a couple spots here on the top right and bottom right corners, which are yellow, which means that the zoning population in those corners is beyond the 500-meter walking distance. And the reason here is because those blocks here are locked up by the other residential blocks, making essentially the travel distance to the nearby parks being too far away. So let me continue the animation. So what I'm going to be doing now as a planner again, let me move some of that residential population to maybe to the west. So I'll go back to the original scenario before I created and placed my parks. I will make another copy of it, so I can compare side by side how it works. And I'm going to take a few of those mixed blocks here and a little bit of low density residential and just unassign them, make them vacant, and move them here to the west of my study area. And now I'm going to repeat the process. So let me again place my parks within 500 meter walking distance and 5,000 meters at least of the size of the vacant lot. Again, this is location allocation solver running behind of network analyst. And as you can see right now, I don't have any yellow areas on my accessibility map. So now let's see side by side, right? Before, after, before, after. Great. So, and this is how the iterative improvement process goes. So I can actually see in numbers in form of this accessibility map and numeric reports what's the level of accessibility to my residential or maybe even business time population is to those amenities and services of this which city provides. So here, similarly, I'm going to place a few ponds here. 1,250 meter walking distance, about 15 minutes walking time. Some larger lots to place a few ponds here and there. Again, the accessibility map is going to be built here and displayed, right? So, and as you can see here now, since I was using a larger cutoff of 1,250 meter walking distance, we can see a much more spectrum here on accessibility to my residential population, to those allocated ponds. So let's see where they were placed. Good. Yeah. So now let's place the non-residential category actually here. So mixed non-residential. This is where people will be doing shopping, where they will be working, where they will get entertained. And here, when I'm going to be doing it, I will be actually using a fairly typical in urban planning metric or way to allocate it, which is based on the target area of chosen zoning category. And here I'm going to specify that again, within 500 meters walking distance from my residential population, but I'm going to specify that target area of chosen zoning category is more than 500,000 square meters. That's, for example, the target value coming from the master plan brief. And there is some optimization on top of location allocation solver, which now takes this metric into account and runs iterative optimization, allocating those blocks. Actually, as you can see, almost all of my blocks now were placed under this category, and I have 98% of my residential population with 500-meter access, walking access to those commercial areas. I'll just take all the unassigned blocks right now and assign them also to be mixed non-residential. And at this point, actually, we have all the blocks assigned. That's my current layout. So let's proceed into the massing model generation. And at this point, this is a neural network. Yeah, I will create again a copy of the scenario here, just in case, so I can return later to it. And here I will be calling them the massing generator model, which runs locally on the same machine, and which now takes into account the road graph, the zoning categories, the densities coming with the zoning categories, and these are BCR, building coverage ratio, FAR, floor area ratio, and the city style encoding, which we can talk a little bit more later, but essentially which affects the shape of the buildings which will be placed into those blocks. And yeah, we got about 2,700 buildings generated. The video is a little bit sped up, but 2,700 building footprints with height information were generated in about 2 minutes or so on this machine locally. These are fairly rough LOD1 shapes, but they are already accurate enough to be converted given the zoning category population density with the buildings calculated GFA into the actual population count for downstream analysis. So we got these buildings placed into the context. So let's take a look at what we got here. Yes, some of them look fairly good, some others may be a little bit noisy, and we have a way actually to correct them. This is procedurally extruded buildings. So it's like native geometry of CityEngine. You can apply your own CJ rules to it, you can manually edit them, you can replace them with your own buildings, imported or manually edited here or generated procedurally here, and it will still work all together in concept. So let's say here I got a bunch of blocks on the south from my downtown core, which is of a somewhat lower density. Let me change the style of those a little bit by bumping up the density a little bit. And here I have this city style dialog, which is a little bit geeky at this point probably, but the idea is that on the left, the planner chooses the density option, which has FAR and BCR on the axis, and on the right, user can pick one of the few options which match this density from all the training data which we used to train this generative raster model here. And in the middle, you can see a quick preview coming from the neural network, which responds to this inputs. So the density, the FAR BCR densities, and the city style encoding here in the neural network embeddings space. So let me play a little bit here with density. So maybe I'll take the density a little bit maybe lower, and yeah, something like this. And how about maybe some other a little bit more solid shapes here. Okay, all right. Sounds like London will be the source of the style here, and I assigned that modified style to those blocks. This is kind of my local infill scenario within the bigger study area. And again, I'm going to regenerate these individual blocks. And I got somehow different shape right now, which matches much closer the geometry which I picked in that style picker. But now I also don't like this downtown core geometries, which are a little bit too noisy. And I would like to change them, maybe play a little bit more with the style again. So I made another copy of my study area into another scenario, and I selected all the downtown core blocks, and I'm going to change the style of them, maybe to find something less noisy equivalent here. So I'm going to again play with density, and again playing with density not just from the aesthetics point of view, but based on the master plan brief specs. Right? And let me see which particular shapes I prefer. Something like this, yeah, clean Brno from Czech Republic. So again, let me regenerate the massing models, LED 1.3 buildings here for my downtown core blocks. And let's see what I got. All right. All right. So let's take a closer look at what we have right now here. Okay. Okay. Not bad. Not bad. Much cleaner. Looks much cleaner. But are they really? Let's compare. Before, after. Before, after. Good. I think I will go with that. So as you can see here, this is an iterative process with me as urban planner adhering to the metrics while being able to actually drive further this urban plan in a single environment, in a single process, in a single workflow, by bringing human to the loop, by not just exclusively outsourcing this urban planning process to the AI or the optimization engine, but also relying on my sense of aesthetics and sense of beauty, using me as a human as the main guide here. So once we are done here with the massing study, and I can of course iterate more and more here, perfecting the building shapes, maybe manually editing them. But let's say I'm done here with my massing model with my buildings. Now what I can do is actually to place critical facilities, because these buildings, they also come with GFA, right, gross floor area, and the zoning categories which they belong to come with average population density. So I convert GFA and population density of the zoning category into the actual population count on the blocks. And now I'm going to be placing critical facilities. I'm going to be placing hospitals here in order to maximize, again, the access to my daytime and residential population. And let's say that my master plan brief has two options to explore. 3 larger size hospitals with about, let's say, 55,000 population in vicinity. And let's see, I'm going to place them in here and see the accessibility layer again, how accessible these facilities are for my population. All right, so this is the 3 locations where the hospitals can be placed, and this is the accessibility map. You see that on the outskirts I got some purple layers, but now let me make a copy again of my scenario and repeat the process for the option B, which is 5 smaller size hospitals of about 35,000 population in vicinity, and the smaller size lot here. So instead of 15,000 square meters minimum, I will be using 9,000 square meters minimum. So smaller size hospitals, placing them again to serve my population. Let's see. And the placing those hospitals is zoning dependent, of course. So I cannot just place hospitals in my residential, low density residential blocks. So that's also plays a role here. And okay, we got the accessibility map and 5 hospitals. Let's compare side by side. And even without numeric reports, I can visually see here that the amount of these purple blocks is much fewer for this option. So I'll go with the option B, right? 5 small size hospitals. And just for the sake of it, I'm going to place 10 schools with about, let's say, 35,000 overall population in vicinity. And now I'm going to be using 1,000 meter walking distance cutoff and use only residential population now, not the business time population, to place those schools. Again, schools can be placed only in certain zoning categories. And here's my result here with the schools placed and with the accessibility map ready. All right, so this is what we got here at the final version with the facilities placed, with buildings placed, with zoning assigned, everything done under CityEngine, and with the help of generative AI and powered by the optimization and numbers driven and verified by the network analyst. So this is the end of my demo. I'm a little bit out of time. I apologize for that, but real quick. So for that experiment, we were using almost 600 urban areas from Europe and Asia to train this generative neural network. It is a powerful and flexible neural network, which we hope to improve even further this year. So this is our first release here, but we definitely have a clear path forward how we can make it better and faster. And that's pretty much it. Thank you very much.
Well, thanks a lot for the presentation. Awesome stuff. I have a lot of questions, but I'm not going to go first. Yeah, maybe or bring in the questions, dear audience. I do have a couple of notes. Just in case there's no question coming in, so I'm just gonna start very quickly. So I mean, it's really cool to see that something like this is implemented within CityEngine, which is, I guess CityEngine is a very cool sandbox for these types of things. But and maybe it's a naive question, but because network analyst is involved and like analyzing street networks and shape analysis and all of those things. So what's the reason to specifically go with CityEngine and not create a prototype like this in, for example, a standard desktop GIS? Kind of how did you choose, or how did the teams working together on this decide to go to implement this within CityEngine?
Yeah, that's a very good question, and I think this is more of a question for the product management, but I can try my best here. As far as we see it, the CityEngine is the primary platform for urban planning. CityEngine in constellation with RGS Urban. These are the main platform for the urban planners and urban designers, and we want to bring this functionality of network analyst and maybe further down the road utility networks and business analysts to bring social economic variables to the urban planner into the single operational environment within which the urban planners can efficiently use these tools and use these data sources, use these variables without a bunch of import and export operations, minimizing the number of manual operations, this way minimizing the number of error-prone stages, making a coherent, consistent, and seamless user experience, maximizing the efficiency of the workflow. And of course, maximizing the efficiency of the urban planner, letting the urban planner to focus on what she or he is doing best, not worrying about the I/O, the format, the ETL aspects of all that stuff. So a single operational environment, single workflow.
I mean that's fantastic to hear, right? Because it within the, let's say, entire Esri universe or ecosystem of tools, that would make CityEngine quite a unique, let's say, tool. Or I mean, it already is, but it would make it even more, let's say, as a powerful standalone thing. But even to use CityEngine as that, or kind of propose to move forward with those things, is something that is, yeah, it's fantastic to hear. But also the choice of going more towards a kind of desktop tool that kind of runs on a machine, rather than pushing these things to the cloud into, let's say, urban or potentially something in the future. I mean, it's a prototype, right? That nothing is set in stone. But at the moment, at least, the notion to do the sandboxing in a desktop, in CityEngine as a desktop tool is I mean, that's cool to see.
Yeah, I agree with you. Thank you.
Sweet. Yeah, no, great work. I mean, there's a ton more questions that would be more kind of on the actual. It's a prototype. I don't want to go into too many of the like AI related, let's say, aspects. So I don't see more questions right at the moment, but I would say let's do another quick break. Let's do 5 minutes and then go into the next presentation. And also to Dmitry, I hope you'll stick around for the discussion afterwards. Yeah. Potentially there's a couple more questions coming in afterwards, but thank you so much for your presentation and for all the work that you and your teams are doing.